Well, thank you, Rachel and Wendy, for the opportunity. I think, within the Syngenta team, Scott, myself, and many of our colleagues jump at the opportunity to be involved in conversations as to how to use our products in a more effective way and a safe way. And nothing probably is more important than discussing application and managing some of the risks involved with spray drift. What Wendy had done prior to today was supply a list of questions or topics that we might address. So we've put together a few slides, and we're going to try to work through and address these over the course of the next hour. I'll talk a little bit, give a little bit of an introduction, and then I'm going to hand over to Scott to go a bit deeper on nozzles. What we're going to try and do is, I suppose, address some of the risks associated with not getting it right, and give you a few things to think about. For some of you, this will be just a refresher, which is great. For others, who may be new to the industry, it's a really good chance to start thinking about what what knowledge gaps you might have. And, spray application is a huge topic, so we're not going to try and cover off everything in an hour. And a lot of this is stuff that really needs to be done in field, but we'll try and give you a few tools today and hopefully prompt a little bit more thinking. So, firstly, why does application matter at all in berries? Well, firstly, fungicides and insecticides are only going to work as well as you can apply them. In berry crops, and the picture here is obviously strawberries. We're dealing with dense canopies, very delicate fruit, which is highly susceptible to infection from various diseases, namely botrytis and powdery mildew, but others. What do we matter? What does it matter to get it right? Well, there's a number of reasons why. It's a really simple conversation. If we don't apply things in the right way at the right time, you're wasting money. They're not going to work as well. You're not going to see the level of control that you would like to see, and that we know that you can get if you use products effectively. Your customers are going to be unhappy because the shelf life of fruit and the quality of that fruit's going to be compromised, and yield loss. The bottom line is impacted. There's a risk that you're using products unnecessarily. You're putting products on at a time or in a manner that they're not reaching your target, or they're ending up off target altogether. And there is a sort of short to medium term risk of introducing resistance to certain pests and diseases where we might be underdosing or applying things in a way that could be contributing to resistance development. And then think about our social license as a horticulture business. There is a lot of overlap between residential and farming, maybe increasingly so in some areas. And there's a lot of focus on, this concept of sustainable production and social license. So we're doing things in a way that's going to look good for our industry and that is going to keep regulators and consumers on side. And the economic loss, which I've covered. So in terms of optimizing application, we're talking about making sure that products reach the target, that they do what we want them to do, and that's done in a way that your business is achieving all of your financial goals. What is good coverage? Coverage is about achieving uniformity of application, a uniform distribution of droplets across all of the target surfaces, and I'll talk about the targets in the next slide. And as I mentioned, with some berry crops, strawberries as an example, There are some challenges that are going to mean that you need to think carefully about the type of equipment that you're using. You might be using old gear, you might be using new gear. Is it working in the way that even brand new equipment set up in the wrong way can end up with poor coverage? We're going to talk about some of the things that you need to think about, in particular droplet size and nozzle type that can help you improve and achieve decent coverage. We need to think about getting spray and products into the plants and onto those target areas. And we need to think about, depending on the type of product that we're using, what does it need? Do we need to be applying it in a way to support uptake if it's a systemic type product? What is the target? When we talk about target, we're talking about two targets. One being a biological target. This is the pest or disease that we're wanting to control, and the other is the application target. Where is that pest or disease likely to be? Is it botrytis attacking flowers? Is it thrips in flowers? Is it mites on the backside of a leaf? Is it in the upper part of the canopy? Is it the soil for some things? So this combination of a biological target and the application target needs to be taken into consideration together, along with timing. When is the optimal time to be spraying for that particular target? So with that, I'm going to hand over to Scott to talk about nozzles. Are there any immediate questions in the chat before Scott kicks off?
No, it looks like Scott's right to go.
Perfect. Thanks, Len. Thanks for getting us to this point. I'm just going to touch on some key things around nozzles. And remember, look, there are people out there that are selling nozzles and nozzle manufacturers, and they are certainly very good people to be talking to about some of the choices you might need to make. Nozzles are really important, and they are one of the biggest factors that can influence the droplet size or droplet control, and also the pressure you're running at. So, if you're running smaller nozzles, you're going to be producing finer droplets in general. And this is when we're talking here, we're talking of the same nozzle. So these are flat fans as a range. So if you're using a flat fan and you're using an O2 nozzle versus a flat fan O4 nozzle, you will be producing finer droplets. There are some pros with everything you're looking to do. So some of the benefits of using or producing a finer droplet is you will get better coverage. You have increased surface area contact, but the downside of using smaller nozzles, finer droplets, is you have a higher drift potential and you have a faster evaporation rate of the droplet. And that might not necessarily have a big influence on your product decision and your application decision somewhere like Tasmania, or maybe the Atherton tablelands because of the environmental conditions, which I'm sure Len will touch on later. But it could have an issue if you're talking about growing berries in some of the drier, warmer climates where the humidity is not quite so high. When you go up to larger nozzles, you'll produce a coarser droplet, and some of the pros or advantages of those nozzles are reduced drift. You can get some better penetration with a heavier droplet, more punch, more inertia. Some of the downsides or the drawbacks are, you get potentially less uniform coverage and you have fewer droplets per unit area. So you do get fewer droplets to cover. And we've got a really good slide that explains that, which is coming up. This shows you just what a little small change can make in application. So on the right-hand side, you're seeing a Syngenta defined nozzle, which is an O4, versus the grower's nozzle on the left-hand side. And this is just some quick work we did at a workshop down in the Melbourne area. And you can see highlight the difference there. The right-hand side, you're seeing a nozzle that's producing less drift compared to the left-hand side as you're looking at it. And just play the video there, Len. You can also see while that video is playing that you're using a significantly lower water volume. And when we actually had a look at those leaves and the fruit after that application, we could actually see improved coverage on the leaves and on the fruit. So we were using less water, producing less drift to give a better result in that situation. So just a simple change in nozzles can have a big influence on things like coverage, the performance of chemicals you're using, your efficiency in the orchard or in the crop in terms of spraying and spraying hours. So a simple change can make a big difference, but I will say, when you're looking at making these changes, please get out in the crop and test them at all times. So get a few nozzles, get a few different types of nozzles, get some water sensitive paper, put some water in the machine and just spray and spray and spray until you can achieve your optimum efficiency. Next slide, Len. As we said, droplet size increases with nozzle size. So, you know, and also pressure has an influence in that. So if you're using an air induction nozzle, for example, when you go from 3 bar, which is producing a very coarse spray droplet, about 300 micron or 380 micron to 460 micron, if you go up to 4 bar, you're then dropping down to a core spray quality, which is running between 320 and 300 micron. So nozzle size has an influence in droplet or spray quality, as does the pressure. Next slide. Just in terms of identifying nozzles, there's a lot of nozzle nomenclature or naming that you will have on them. And you'll see on a nozzle, when you look at it, you'll see the nozzle type, which is generally defined by an XR or an AI or a low drift or a mini drift. You'll have the nozzle brand. You'll also have the spray angle, so it will say 110, it might say 90, it might say 80, depending on what you're doing. And then it'll give you the O4. Now, the O4 of a nozzle relates to it delivering 0.4 gallons per minute at 40 PSI. So an O2 nozzle will deliver 0.2 gallons per minute at 40 PSI. So that's how they define the nozzle size is in terms of what it's delivering in gallons per minute. And generally they are a standard color. So an O1 will be an orange, an O15 will be a dark green, an O2 will be a yellow in color, an O25 will be lilac, blue for an O3 and red for an O4. So it makes it very easy to identify what nozzle type or what nozzle size you're using. And then you have the material that it's made out of, whether it be plastic, stainless steel, hardened stainless steel, ceramic, VisiFlow, even spray, and a whole range of different materials. And they all have different characteristics in terms of how quickly they'll wear and how quickly they might need to be replaced, depending on how often you're spraying. Next one, then. And nozzles are quite an interesting thing when you start delving into different nozzles for different crops. And one thing that Syngenta does, we not only develop agricultural products for use in crop to manage disease or insects or weeds, we also look at how to get the best out of our products. So we have a department within Syngenta that identify chemistry and bring chemistry to the market. We also have another group of people that work on how to get the best out of that chemistry. And from that group, we've actually been able to come up with several different nozzle designs. And we have an air induction nozzle that we've developed, which does have an angled tip in the nozzle. So it's a 10-degree angle, was originally designed specifically for spraying fungicides onto the head of wheat crops in Europe, where they have very dense crops and they need to protect that head against fungal diseases. It is quite a unique nozzle. It's sold as a Guardian air induction nozzle, that it has more droplets per litre as an air induction nozzle than nozzles of equivalent size. And it has certain fits in different crops as well. So in Australia, we recommend that in carrot crops, for example, as a nozzle that gives preferred application strategies. We've also developed a vegetable nozzle, which has some unique characteristics. It's a 65-degree fan angle as a nozzle, which means you can actually run it higher. So if you're using a 110-degree standard fan, you should be running somewhere between 40 to 50 centimetres from your target area to get the optimum overlap at a 50-centimetre row spacing. And depending on your situation, achieving that spray height, that boom height evenly across the crop can be quite difficult. Running a 65-degree angled fan at a 50-centimetre spacing, you can go to 65 to 70 centimetres above the crop and get your double overlap. So you can actually run higher and still effectively produce what you want to do. So we recommend them in certain crops and crop situations. And then we've developed the Syngenta Defy nozzle, which was really specifically developed initially to be used in potato crops, where we have a real challenge getting fungicides down onto the lower canopy of a crop. And there are other horticultural crops, and then talked about the denseness of strawberry canopies and different crop canopies. Potatoes are very difficult to get spray penetration down onto the lower canopy, and generally a lot of the diseases in a potato crop come from those older leaves as they're senescing. They're more susceptible to disease, and it's just a sink of diseases coming up and affecting the top crop or the higher parts of the canopy. And we found through our work and actually going into the crop and measuring where we're putting products, that those nozzles delivered more fungicides to the bottom of a crop than many of the other nozzles that growers were conventionally using. So it's a different, as I said, it's not one nozzle suits every single application you might be doing. It's around mixing and matching what gets you the best result. Next slide, then.
Sorry, can I just ask
Yep.
a question before we move on from nozzles? Obviously, you've got some pretty specialized nozzles. Now, I'm probably the least experienced in the room when it comes to nozzles, but do you have any that you particularly recommend for berries?
As you saw, Rachel, a really good question. The Defy 3D nozzle was the nozzle that was in the video. Now, what we find from a berry crop when we're trying to deposit fungicides, depending on your chemistry, and it will depend a lot on the chemistry you're choosing and what you're applying at what stage, but you do need to get coverage with certain chemistries underneath the berry leaf. And to do that, one of the ways we find very effectively is using air. And there's a lot of machinery manufacturers. Croplands have some very good technology, as do Hardy, with using air to improve coverage underneath the underside of the leaves. We found if a grower doesn't want to go to the expense of running an air-assisted sprayer, which can be, require more horsepower in some situations, they generally are a little bit more expensive. In the meantime, before they can do that, you can actually improve the turbulence in and around the crop by angling the spray. So we found in that situation on the video, it was the 3D nozzle that performed quite well in that situation. I've got a couple of people that are using them and putting them on berry spray rigs at the moment and getting fantastic results. Not necessarily so well suited for knockdown situations for herbicides. If you're looking at a ground preparation situation where you want to prep the ground to go and plant into, in that situation, we'd recommend an air induction nozzle, because they are more likely to reduce the amount of drift you might be getting from the herbicides. Len talked about the social license. The last thing we want is people driving past a property or a paddock and seeing all the spray drifting into the air and going, they're not doing a really good job. So each of those have a different use and will have a different purpose and benefit. It's very hard to recommend one nozzle that will do everything a grower wants to do.
Okay. And but next question, is there any, because obviously in berries, we have quite a lot of protected cropping too. So is there a difference in the type of nozzle that you would use in a protected cropping scenario than in an open field scenario?
You could probably get, it just depends on protected cropping. I haven't done a lot in big protected cropping berry situations. I've done a lot in protected tomato crops, where we're spraying quite a wall of tomato foliage. And in that situation, we were going to an air induction nozzle to get a bit heavier droplet to help carry into the canopy a little bit further. And we were using the one on the top there in that situation for that vertical spraying target, because it's a different target to spraying horizontally and achieving coverage around the crop.
Great, thank you.
As we said, you've got different spray qualities. Fine droplets are ideal for contact products on exposed surfaces. So when we're talking contact products, they're products that don't need to penetrate into the plant leaf for them to work. So a good one for that would be, from a downy mildew point of view, would be something like a copper or a mancozeb or a contact product. From a powdery perspective, if you are using sulfur, that is a contact product. It doesn't penetrate into the plant surface. Fine droplets, good coverage is important for that, but they can really struggle with penetration through the canopy because they don't have the weight in the droplet, the inertia to be able to punch through the canopy. Medium droplets are, often a good compromise for general coverage and reduced drift. And then we go into coarser droplets, which, generally, if you're needing something like punch is better for penetrating dense canopies, but certainly reducing drift. But because of the nature, you're getting less droplets per centimetre squared. you might get less uniform coverage if you're not setting your spray up right, and you get less surface area of the leaf covered. Droplet size, sorry, yep, that's all right. So and the example here is a perfect example. So a 500 micron droplet, if you halve your droplet size to 250 micron, you'll get 8 times more droplets. If you go down to 125 micron, you've gone from that 500 micron droplet to 64 droplets out of the same volume of water. And you can imagine going from one droplet to putting 64 on that leaf, you're going to get much better coverage. But then we talk about the impact of having smaller droplets on droplet survival, and that comes up a little bit later in the presentation. So in terms of retention and adhesion, and one of the comments I'll make, and I make this in most crops I go into, it is extremely rare, and that rare that I probably haven't been in a situation for at least 5 years where I've gone into a horticultural spraying operation, whether it be a fungicide, a berry crop, a tomato crop, a potato crop, a grape crop, or even mangoes and avocados. Citrus a little bit different, where I would suggest that I would expect the grower to use and increase their water volume they're currently using. In the vast majority of situations, I recommend the grower reducing their volumes, because I find a lot of challenge with people retaining spray on the crop. And it could be using too fine a droplet, but it also could be using adjuvants or just the sheer volume of water that people are putting on, that they're actually washing product off. Very coarse droplets, on the other hand, may also bounce. So we need to get a mix, an optimal droplet size to ensure good adhesion to the crop. And that's what we're trying to do. We're trying to adhere our botrytis fungicides to the berry. We're trying to get our powdery fungicides onto the leaves and onto the fruit to protect that. We're not trying to wash it past, and there's no point putting it on the ground. It's no point protecting the plastic against disease, because we don't need the product there. In terms of contact, go back, Glenn. For systemic products, uniform coverage ensures sufficient uptake. For contact products, direct contact with the pest pathogen is essential. So you need uniform to get product in. So systemic products move into the plant to work. Contact products stay on the outside of the plant to work. So they will perform differently. One of the issues we do face, and this is where it comes into, protected cropping examples, going down to Tasmania. I've done a lot of work over in New Zealand versus some of the more inland berry growing areas where you tend to have warmer days and lower humidity levels. Fine droplets can evaporate very fast. The quicker a droplet dries, the less product you're getting in, and very important for products that are systemic and need to get into the plant. So products like the saprodinal component of switch, Miravis Prime, the phytoflumethafen component of Miravis Prime, and anything that some of the DMI, the group 3 chemistries that need to get into the plant to work, can only get into the plant while that droplet is wet on the surface of the leaf. Once that droplet dries, you get no further uptake. It's finished. So the systemic products, whether it be an insecticide and a fungicide, and it's very important for herbicides when you're looking at weed control, as soon as that droplet dries, you get no further uptake of the leaf. So it's very important to match what you're trying to do with the evaporation rate of the droplet. And that's where following delta T is very important. And I'm not sure whether Len covers off on delta T a little bit later on, but it certainly is very important to follow delta T when you're spraying. Next slide. Just some different sizes here. So you've got a 50 micron droplet. It's considered an aerosol. Evaporation time under delta T of 10. You're looking at 3 seconds and traveling distance of 12 centimeters. So if you're producing an ultrafine aerosol type spray, you've got 3 seconds for that droplet to be what we call alive on the leaf and allow the product to get into the plant. When you go up in droplet size to 50, 100 micron, it's considered to be a mist. You're looking at 13 seconds survival. And it travel a distance of 1.9 meters. When you go up to 100 to 200 microns, you're getting a fine spray. And under the same environmental conditions, you're getting a lot more survival of that droplet on the leaf. That's why we sort of try and target that, that 100 to 350 microns. So we get a mix of coverage, we get a mix of a good droplet survival. We get a good mix of foliar penetration. We really want to try and get as much in that range as we can. But there are some situations where we do need to go to a medium coarse or very coarse droplet. And we do need to manage the risk of bounce and runoff, and we can do that with a choice of surfactants. We can do it with water volume. There's a whole range of ways we can manage the risk that is occurring with droplet survival. And when we talk about penetration and movement and sometimes the benefit of air, so large droplets generally move straight down or straight across. And when you're seeing here is a mix of spray quality. So you're seeing the big heavy droplets, you've got a berry on the plant there. Those big heavy droplets are going in and hitting the front of that berry, and that's where they're staying. They're not bending around. They're going past the berry, or they're hitting the berry, and they're not really coming around to protect the berry. And many of our products, we need to get thorough coverage and even and consistent coverage across the whole berry surface. To do that, what we need to be able to do is we need to be able to get droplets that will actually move in air currents. And you can see there some of those smaller red droplets and some of the smaller yellow droplets are actually moving in the turbulence in the air that we're creating, the air that's in the canopy, the natural resistance of the canopy itself. And they're bending around and depositing themselves on the back of the fruit or on the underside of a leaf or on the back of a leaf. So we do need a mix of spray qualities to ensure that we're getting good effective coverage on the front of the berry, but we're also evening up our coverage on the back of the berry. Water volumes, again, as I said, I touched on water volumes are really critical to get right, and they should be matched to the canopy at the time of spraying. So smaller canopies, smaller crops require lower volumes to reach point of runoff. Bigger canopies, bigger crops, more dense crops would require a higher volume to reach the point of runoff. And I'm not saying you have to apply everything at the point of runoff, but the point of runoff for some of the products you're using, when it's just a rate per 100 litres, is very important to calculate so that you can get the dose rate right. So low volumes can be incredibly efficient. They do require smaller droplets or smaller nozzles, and you can do that, as I said, using an air induction nozzle. You can get the volume down, but still producing a good size droplet in terms of that. And precise application to ensure you get even coverage. They do have a high risk of uneven distribution if you're not getting it right, and lower volumes, smaller droplets, faster evaporation rates. High volumes can provide more thorough coverage, wetting and penetration, and generally can be preferred with certain products, and higher volumes are always preferred with miticide applications versus lower volumes. So if you're doing a miticide, you should be keeping your volume up to the higher end of what you can do, not trying to get as low as possible. The downside with high water volumes is they can lead to excessive runoff. So, it's very important to make sure you're calibrating your machinery. And I always ask the question when I'm in an in-person group, how often do we manually calibrate our sprayers a year? Or do we rely on the equipment in the cab telling us what we're doing and not actually manually cross-referencing that with what's actually happening out of our nozzles and doing a manual calibration? Because things can change, and tractor to tractor can change on the same spray rig. So it's always good at least once a year, or I try and get people, there's a couple of times a year where it's really important to make sure you're maximising your spray. Get out and just do a quick manual calibration just to ensure the rate controller is telling you what's happening and it is accurate enough. So, summary is appropriate spray volume in conjunction with nozzle choice is crucial for achieving the desired coverage and getting the result that you want to get. And you can sort of see here visually a good representation of what a fine spray quality is: medium, coarse, very coarse, and extra coarse, and different water volumes there. So you can see really good coverage with a fine sprayer at 125 litres, really uniform coverage. You can see as you're going up in spray quality, you get gaps in the protected area. So it's really important just to match what you're doing, the chemistry you're using, the environmental conditions at the time with what you're trying to achieve. Yeah. The goal is and always should be to achieve even coverage and making sure that that even coverage is getting distributed across the most area on the leaf surface you're trying to target. So 50% coverage here with good distribution, or you can have the same level of coverage but poor distribution and holes in your disease or your insect control program. So we try and get as good a coverage as we can distributed across as much of the leaf surface or berry surface that we can. In terms of product choice, again, you're looking here to get your eye in. You've got 20 droplets per centimetre squared, 60 droplets per centimetre squared, and 100 droplets per centimetre squared. And depending on what you're targeting, whether it be an insecticide and as a mobile insect, and whether you're using a systemic insecticide or a contact translaminar, herbicides, whether it be a pre-emergent herbicide or a post-emergent herbicide, and fungicides, again, broken down into systemic or contact translaminar, we do have a recommended droplet per centimetre squared that we're averaging. So for a mobile insecticide, you should be looking at 60 to 100. So you at least should be trying to achieve that centre yellow water sensitive paper there result, and somewhere in between there and the 100 droplets per centimetre squared. If you're doing a pre-emergent herbicide, you could get away with effectively doing the water sensitive paper that's on the left-hand side, which is 20 centimetres. And with fungicides, if you're using something that does penetrate into the leaf surface, you should be looking at somewhere between 20 to 30 as a minimum. So in between the 20 and the left-hand side and the centre water sensitive paper. If you are using a contact insecticide like a mancozeb or a copper or a sulphur, you really should be aiming for 50 to 70 droplets per centimetre squared.
Thank you, Scott. I'm going to jump in, but before I do, any further questions to this point?
Look, we've just got a comment from Stephanus from Biological Services regarding the use of microbiological pesticides, biofungicides. I'm not exactly sure what this means, but it says the spray recommendations from overseas usually state do not spray to runoff, whereas this is the case with pesticide sprays. The topic will get more complex going forward. So I think that's largely a comment. I'm not really sure, but feel free to clarify, Stephanus. And then secondly, Jane, who's our comms manager, is wondering if you have a simple guide that we can share for sprayer calibration.
Yeah, definitely. I'll tackle the first one. And there's a lot of confusion out there in a lot of crops. And you'll see in what we term as tree and vine cropped or trellis crops, the APVMA moved away in the early 2000s from a chemical rate per hectare to a rate per 100 litres. That rate per 100 litres to get the effective dose is worked out on applying that product up to the point of runoff. And we don't advise going past the point of runoff, but that is applying up to the point of runoff. Now, we're not saying on labels, and this is where it's probably whole nother session when we have some time.
Can I just check, Scott, when I come from a water background, so runoff, you don't mean running off the soil, you mean running off the leaf or fruit? Yeah,
off the leaf. So point of runoff is where, and point of runoff will occur at different points, at different water volumes at different points in the canopy. So point of runoff for me is where the droplets that you're applying, like the water sensitive paper here, start to join together to make bigger droplets. So we call that coalescing together. Now, point of runoff will occur at lower water volumes on the outside of a strawberry canopy than it will on the inside of a strawberry canopy, but we're targeting diseases on the inside of a canopy. So we need to be calculating point of runoff at our target zone, and Len talked about the application target. So if we're talking the fruit, that's what we're protecting with what we're applying, that's where we need to be calculating the point of runoff, not the outside of the canopy, because the water volume will be different to be point of runoff. We're not saying, for example, in a strawberry crop, that could be 1,000 litres of water. We're not saying a grower has to apply 1,000 litres, but that's how they have to calculate the dose. Fortunately, in some crops that some products that you deal with, they do have a rate per hectare, which makes it a little bit simpler in a way of calculating how much you should be applying over a given area than a rate per 100 litres. But that's a whole nother conundrum of discussions. And we're really having challenges with that in some of the crops like macadamias and avocados and mangoes at the moment, and we've been dealing with it in viticulture for a long, long time.
Thank you.
And we will provide you some material sharing the presentation, and we have a large volume of material around calculations and calibrations that we can share and make available.
Awesome, thank you.
Great. Well, look, one of the questions was, should I can't remember the question exactly, but basically, should I be considering the environment when I'm spraying? Temperature, humidity, absolutely. As Scott has touched on right the way through, temperature and humidity will change over the course of the season, and depending on the droplet size that you're using, the outcome in terms of your pest and disease management program can be very, very different. Smaller droplets are going to evaporate faster as it gets hotter and drier, and product may not get into the plant, or and I guess we're going to see a lower level of efficacy. As those cards that we've just showed, you can offset coverage in some cases by increasing water volume, but we've got to be careful when we do that not to be doing so in a way that's going to increase sort of beyond the point of runoff. The delta T, one of the other questions was, is there value in having weather station on my farm? And yes is the answer to that. While temperature might be fairly consistent across a large geographical area, when you start looking at the humidity or rainfall on a particular property, I've seen firsthand the difference within a very short, particularly in areas, think about the Yarra Valley, any area that we might be growing in that has hills, gullies, creeks, shelter belts. All of these things are going to impact the microclimate at the plant level, and therefore having a weather station cleaned, calibrated annually or as often as required is going to give you much better visibility on the environmental parameters on your farm, which can be quite useful later when it comes to investigation of things like spray drift incidents, or even just evaluating how effective my program was, what worked, what didn't, why did we see better control, why didn't things work quite as well. So having that sort of granular data for your own site is, and it's affordable now as well. Delta T is a much better indication of evaporation rate than simply looking at temperature and relative humidity. It's calculated by subtracting the dry bulb temperature from the wet bulb temperature. And there's a range between 2 to 8, which is considered sort of optimal for spray application, as the chart indicates. So that delta T can be, there's apps. They've been around for a long time. There's an app which your operators can look at to check the delta T, and then taking into account things like what spray quality am I using, what water rate am I using. You can start to think about whether or not you need to be adjusting spray quality for the typical environmental conditions that you might see at flowering in your situation. Higher delta T simply means that droplets are going to evaporate faster, and remembering some of that earlier stuff, the smaller the droplet, the faster it can evaporate. Less chance of that actually reaching your target, and less chance of uptake of that product once it does reach your target. I'm not, in the interest of time, I'm not going to cover really this stuff in too much detail. Outside of nozzles, there are a heap of other factors to think about that are going to impact on both your coverage and keeping your sprays on target and on your property. Those are relating to pressures, your ground speed, the engineering relating to your sprayer setup, your boom type, the nozzle angles, fan speed if you're using air assist, and then the environmental conditions, and whether or not the products you're using include an adjuvant, or whether one is required, or whether you've added one. What I would say is, if you're going to look at evaluating and optimizing your setup, don't change everything at once. takes a bit of time, but what you need to be doing is incrementally improving things. The first step might be evaluating a second nozzle. Great, do that. The next step might be looking at speed or say your fan speed, but just don't change 3 or 4 things at once, because you won't be able to work out what actually led to the change and improvement. And the other point I'll make here is, the people that you really want to be educating around application and the people that you really want engaged in terms of getting it right are the people that are sitting on the tractor. So the people that need to be involved in this sort of evaluation and the post-season debriefs where we look at what worked and what didn't and what we can do better next year, engage your operators. And in a small operation, that might be you, but in a larger operation, an annual opportunity to get the equipment out of the shed, because you want your operators looking behind them, looking for block nozzles, coming to you with insights as to how good that coverage looks and what's working.
So, guys, we do have a question. Sorry, I got distracted by another message. Did you get the question around delta T reading?
No, I haven't seen it in the chat, but
okay, it says how do we go with delta T reading inside a polytunnel, as temp and humidity is very different to outside spraying?
Yeah, definitely, Rachel, and I can just jump in there. So you can buy little handheld devices now that actually measure the temperature, they measure the humidity, and you can actually even get them, they're called Kestrels, and there's a whole range of different ones, and there's some and if you look on the web, there's lots of devices that will help you measure delta T. So you can take the unit inside the protected cropping, inside the polytunnel, and it will tell you what the delta T is in that environment. And I would always suggest that if you don't have weather stations on farm are really good, but if you strictly follow label directions, it says that you should record wind speed, wind direction, and temperature and humidity at the site of spraying. So a handheld device, for the sake of a couple $100, even $500 for some of that Rolls-Royce equipment, at the tractor, at the point of spraying, covers all of those bases. And that's actually a legal requirement.
Okay, so maybe could you do us a favour and throw a link in the chat for one of these gizmos?
Yep.
So that we can make sure you're suggesting the right thing. Thanks for the question. All right, moving on.
Perfect. Thanks, Scott. Another question was relating to rain fastness. Look, I've got one slide here to cover that off. Point I will make is that rain fastness does not relate to the environmental runoff warnings that you see on labels. I've had that question a bit recently. Hey, you guys are saying the product's rain fast in an hour, but I see a comment, there is a label requirement that we don't spray this product if heavy rain or irrigation to runoff is going to occur within the next 3 days. Those are two quite separate things. The environmental warning on the label relates to the risk of runoff and conditions that might lead to overspray on your soil, running off into, say, waterways. The rain fastness period is what we're talking about here, which is how long before rain, or how long do I need between applying the product and rainfall for the product to be effective. And that is different for every product. We do that for testing. The product here, which the example I give with the data here is I've just taken this from a Kibra Ultra, which is a downy mildew fungicide we've just had registered for downy mildew and grapevines. And what we do is we look at the efficacy of the product before, with and without rain. And in this case, you can see after this was 60 mils of rain, after 1 hour, the efficacy has been maintained. And with that, we can safely say that Kibra Ultra is rain fast in 1 hour. It's not always as simple as, okay, it's a contact product, therefore it's going to have a longer rain fastness period, or it's going to wash off the plant. It's a systemic product, so I can put it on and not worry about the rain. It's important to understand from your agronomist or from us what the rain fastness is for that particular product. And I'll give you 3 examples there. Bravo Weatherstick is it's a contact fungicide, chlorothalonil, but in this case with Bravo Weatherstick, it's formulated to be more rainfast than, say, a generic chlorothalonil product. Ridimil Gold MZ includes metalaxyl-M, which is a highly mobile systemic downy mildew fungicide, Oomycete fungicide. But Ridimil Gold, in being so systemic, is soluble. It doesn't have it doesn't bind tightly to wax, and therefore we have a 6-hour rain fastness period because we need to give that product time to move into the plant so it's not washed off. Miravis Prime, which you may know for botrytis and strawberries and powdery mildew, is a combination of a systemic and a contact fungicide. Both of those have a lower solubility and a high affinity for wax, so they bind strongly onto that plant, and one of them will move into the plant over time. There was a question on relating to crop damage. What do I do if something's gone wrong? The first step is really contacting your retail agronomist. Always there will be an investigation, whether that's you and them. Every investigation I've been involved in, either with my time, in Syngenta or prior to that, accurate record keeping is critical, and not jumping to conclusions is really important. You need to be able to think objectively, and don't jump to conclusions and potentially overlook a cause. If we ever get involved with that, we're going to want to see good documentation. We're going to need good communication. And the more information that you can collect at the time, the better, because symptoms change quite quickly, particularly for crops that are growing rapidly. So good photographs, high resolution photographs, any mapping, detailed notes of what type of injury are you seeing, how widespread is it? Is it a corner of the paddock? Is it on a fence line? Is it right the way through the block? Is it the upper younger parts of a plant? Is it the older tissues? That sort of thing. Scott, anything to add there?
No, you covered it very well, Len.
Great, and yeah, the highlight at the top is make sure you don't end up in that situation. By reading product labels. If you're using or mixing things that you're not sure of, ask first, or test small areas first.
I think one thing that is pretty important to remember with that, part of the Syngenta development program, and all companies' development programs, whether it be BASF or Bayer or Corteva, is to test crop safety. And we have to prove to the APVMA to get a product registered that it is safe on the crop following label directions. So we do spray crops that it has to be across multiple states, across multiple seasons, to be able to test that and show the APVMA that under label directions and following label directions, the crop safety of the product is confirmed. And the same with compatibility. So when we know that something is likely to be used with a product, and all companies are the same, we will test that for compatibility, for the fact that it's not going to reduce the efficacy of the product you're using, and it's not going to increase the risk of potential crop damage. So there's a lot of testing that goes on in terms of crop safety for many of these products that are registered. I'm
just conscious of the time. I don't want to rush through this topic, but what I will say is we've probably started to cover a bit of it already. There is more information available online, and we'd be happy to follow up at any time. But really, if you've done everything right to this point, you've selected the appropriate spray quality, you've got your sprayers set up in the right way, you've followed the restraints on the label, you've done everything right. You have followed the guidelines in relation to downwind buffer zones, then you shouldn't be in a situation where we are experiencing drift. In the last 20 years or so, I've had the opportunity, or perhaps been misfortunate enough, to have been involved in many investigations relating to spray drift. both at an industry level, on behalf of industry, at a grower level, dealing with problems from over the fence, and also dealing with internal problems where our own operators have got it wrong. In every situation that I've investigated, good record keeping has been critical. It's about protecting yourself as much as your neighbours. When the time comes that an accusation's made about a drift complaint, it doesn't just impact you. Excuse me. It impacts on your on the industry as a whole, particularly if it ends up in the media. So preventing that is really important. Excuse me.
While Len is recovering, I think I cannot emphasize how important this is in terms of social license, and any of the growers who are here from northern New South Wales will understand the level of scrutiny and concern. Now, most of the time it's not founded, but we need to be not just doing best practice, but better than best practice. And I think it's really important that we get this stuff right. Len?
Yeah, thank you.
Yeah, I just sort of add a comment in there. I know time. I had a very good example last year in Pukekohe, which is a vegetable growing area in New Zealand, very close to Auckland, getting a lot of encroachment from urban development. A major potato and onion grower there, we were looking and working through them with application, and a simple change in nozzles. When we looked at the boom from behind, we could actually see all the drift and all the mist coming out from his nozzles. And on the side that we changed to a different nozzle setup, it didn't even look like they were spraying. So they were driving down the paddock, and you visually could see half of the boom spraying, and you couldn't see actually anything coming out of the other half of the boom effectively, but visually, because it just wasn't producing the fines, and it was significantly reducing the risk of drift.
Yeah. Think about things like cycle paths, this ecotourism, and to get people out into the regions. You've got much more chance now that there's going to be a cycle path, but it happens the other way. I was involved in one investigation where we were talking about a very sensitive area. In this case, it was a primary school in a rural area that had been there for over 100 years, and the crops had moved around the school in this case. And it was a really awkward situation because many of the kids at the school were kids of growers. And so, other situations where we've had, relationships between neighbours destroyed for, 10 years or more because of accusations about things that have gone wrong. Record keeping, prevention, having a weather station and having those records of the conditions under which your spray was put out all become really important later. Looking at some of the things here, what is spray drift? It's essentially when it's moving away from the area where we want to target. All of those risks, you've probably had time to read that and that the slides up, and at the time that the slide's been up.
But yeah, I mean, I think for, our growers who do operate in those peri-urban areas, and that's becoming increasingly common, you've got to get this stuff right. And if you're not sure, speak. Like, can I just say, if a grower wanted to get their spray drift assessed, who would they, where should they go? Who would they ask?
Well, I think as Scott just pointed out, it's fairly obvious, but it doesn't hurt to get a second opinion. So, it's very hard to tell from the tractor. You need someone standing behind the tractor. And if you've done these things here, like, optimize boom height, your sprayer's calibrated properly, you're using the right type of adjuvants, which could include a drift reduction adjuvant in the case of, say, a herbicide. You need to be behind the machine and have a plan in place. I don't know how many of the people on this call have or are required to have a spray management plan for their property, but that was something that I always had in place, and it was renewed annually. Where are the sensitive areas? How are we going to manage those sensitive areas? yeah, these are some of the tools here that you might be doing. You know, it could be artificial shelter belts, it could be existing shelter belts. Where are we going to place a weather station? Simple things like a windsock, having a very visual indicator on a boundary near a sensitive area. So if your spray contractor or your spray operator turns up early in the morning because that's been deemed the best time to spray that boundary, they've got a really visual cue as to wind direction. This information here, some of this information here I actually took directly out of one of your industry resources, the Berry Plant Protection Guide. There's a really good section in there, so those of you on the call that haven't read that, take half an hour and have a read through that. There's some really good information in there which I found useful, even though I've been thinking about it for a few years. I'll just make one comment on downwind buffer zones. So those are relating to sensitive areas. Moravis Prime as an example, some of the products that have been more recently registered, you will see have these tables that include these downwind buffer zones. And the key word there is downwind, because if the wind is drifting back away from those sensitive areas, then we're okay to spray. In the example here with Moravis Prime, we have a 5 metre downwind buffer zone for natural aquatic areas. So in the case that that any wind is drifting towards that, you need to pull up at least 5 metres from that. Of course, there's some sense there. If the wind's blowing heavy, it's going to need to be further, but there are certain situations where you wouldn't be spraying over a certain wind speed.
Yeah, Len, I'm very sorry. I have to personally go. I have another commitment, but I think if you've got some more time and folks are interested, then, you know, please don't stop on my behalf. Wendy can wrap it up, but I just wanted to say a big thank you to you both. It was really fascinating. I know more about nozzles than I ever thought there was to know. And I really appreciate your time and the support that you're giving our sector. And I do hope that the growers on the webinar enjoyed it and have got some new things to think about. And thanks for the shout out to the Berry Plant Protection Guide as well. So thanks, guys, and see you next time.
No problem. We've just got a couple more slides. So Wendy, depending on what you want to do, we can pull it up or
No, no,
continue
I'd like
for 5.
Yeah, definitely continue to 5. Sorry, I did ask a question and I've realised that I've addressed it to hosts and panelists rather than everyone. So everyone's seen the response, but not my initial question. And it was in relation, because I think this is something important. It was not something I was aware of. Earlier on, you highlighted the differences between Bravo Weatherstick and generic chlorothalonil. And I asked, are there typically differences between formulations from different companies that have the same active? And Scott said, yes, there are significant differences between products with the same active ingredient formulated by different companies. So that is something that, you know, obviously our growers should take into consideration when, I guess, recording efficacy.
Yeah, a simple example, Wendy. We have a product that's sold in multiple crops in Australia. In our formulation, we contain an adjuvant and an antifreeze in the formulation for stability and to actually improve the performance. 60% of the generic equivalents of that product we tested failed to contain an adjuvant, and 40% of them didn't have the antifreeze in the formulation. So it didn't perform as well, potentially efficacy, if you got things a little bit marginal, and it didn't have the stability for on-farm storage that our formulation had. And there's reasons they are sometimes left out. They might choose a cheaper alternative, or they might choose to leave something out simply because they're buying it from someone who they don't know how they control the manufacturing, or they just choose to leave it out purely to reduce cost. But there can be big differences between the same, what you deem as a 250 gram per litre product formulated by Syngenta, and the same goes for Corteva. Corteva have formulation chemistry and they formulate the product to get the best result from the product, and the same with Bayer. There's a lot of other products out there that might have the same amount of active on the label, but they don't actually contain the same ingredients in the formulation.
Awesome. Thank you for clarifying that. And yeah, if you could finish off the slides, that would be great.
Great. I've got one more, and then I'm just going to pass to Scott for a couple to finish. I just wanted to point this out. I find this quite interesting. As I was saying, we see these sometimes restrictions around downwind buffer zones to sensitive areas, or which can be defined as an aquatic area or other sensitive areas, say a neighbouring orchard or a school, or in this case, a waterway. A waterway is defined as a natural creek or river or natural watercourse. It doesn't include artificial watercourses per the Commonwealth Water Act, as I've got on the screen here, or watercourses that are dry at the time of pesticide application, or puddles. It's just worth keeping in mind some of the, depending on the product, I mean, 5 metres is a very short, it's almost not, it's a very short buffer zone. These can sometimes, depending on the crop and the type of product, can extend out to 100 or 150 metres. So I'm not sure whether there's anything registered for strawberries. I think that would be probably deem it as a product you wouldn't be using. Scott's going to just cover off some points here on the shelf life of chemicals and ChemClear, and then we'll wrap up.
Quite often we might get a call about a product and it has a date of manufacture on it, and how long is the product suitable for use. All agricultural chemical products can undergo changes during the time they're transported, stored, and they include chemical and physical changes. So one of the worst things you can have for chemical storage is going from hot to cold, and doing that over quite a number of cycles. So if you've got them stored in a shed that's exposed to really cold environmental conditions and can get very hot, it can have a significant impact on the stability of the formulation. Those changes do occur at different rates, and they depend on the nature of the active constituent, the non-active components, so all the other stuff that Syngenta might put in, which could include adjuvant, it could include a buffer, it could include stickers, it could include formulation suspension agents. The product will be continued to be deemed fit for purpose if these changes had no adverse effect. As a leading R&D crop protection company and other leading R&D crop protection companies, Syngenta spend many years and do lots of trial work and millions of dollars on the formulation development. And we include testing the shelf life of our crop protection range in Australia under conditions recommended by the APVMA, and we have different conditions recommended by the ACVM in New Zealand. This trial work is backed up by many years of real-time storage stability testing. So currently at this point in time, all Syngenta products have a 3-year shelf life from the date of manufacture. That means that we guarantee the formulation quality is not impacted up to 3 years of storage on farm or in a shed. So if you're buying a product that was manufactured 18 months ago, it's still good to have on your farm and use for the next 18 months. So it is 3 years shelf life from the date of manufacture. In terms of ChemClear, how the program works, ChemClear provides a safe and responsible way for agricultural and veterinary chemical users to dispose of unwanted, outdated, or unknown chemicals. And basically the program is pretty simple. You inventory the chemicals you've got, you make a list of the unwanted or outdated ones, you register those with ChemClear, you store them safely away from people and animals, and ChemClear will send you a storage sticker to help label and identify those chemicals until collection day. You then drop off those chemicals at your ChemClear nominated point, and they are then disposed of safely, which is generally incredibly high temperature incineration. And it's a very costly exercise to undertake. That's why it's good that there's industry bodies that do that.
Excellent. We did have,
Yep.
We did have one question in the chat, and it related to adjuvants. One of our growers has asked, are there different types of adjuvants? They're currently using silicon-based products.
Yeah, and I did put a comment on when Len had about adjuvants impacting drift and coverage and things like that. I did put a comment on earlier, and my comment is, and always will be, if the label recommends an adjuvant, use the adjuvant recommended on the label. Do not go and use a different adjuvant that is not recommended on the label. Syngenta spend between 10 to 15 years trialing our products. And first and foremost, we identify what rate of product will control the disease. or insect or weed. And then we determine, is there an improvement in that level of control by using an adjuvant? And then we'll test all different types of adjuvants. We'll test methylated seed oils, we'll test organosilicons, we'll test modified organosilicons, we'll test non-ionic surfactants, we'll test acidifiers, we'll test a whole range of different surfactants. And if there is an improvement in performance in any particular type of adjuvant, and it's in our best interest to put that on the label, and it is a statistical improvement in disease or insect control, we'll put that recommendation on the label and we'll actually recommend the type of adjuvant that will give you the best performance. If the label does not say there is a need to add a surfactant or an adjuvant, there is no need to add one. And you can actually cause more damage and increase risk of adverse effects by putting in an adjuvant in when one is not recommended. So takeaway message of anything, if the label says to add an adjuvant and add the adjuvant recommended. If the label doesn't say to add a wetter, there's a reason it doesn't say to add a wetter or an adjuvant, because it's not needed. And all you're doing is spending more money than you need to on the product.
Thanks, Scott. Well, look, I've got, realising that we're well over time, thanks to those of you that have stuck around. I guess I've got two challenges out of today's presentation for you. The first is, if you're not doing it already, I would challenge you to annually be evaluating your spray equipment, not simply calibrating, but looking for opportunities for improvement and engaging the right people on your farm to do that, namely, whoever is going to be operating the equipment. And the second one is, if you don't, I don't know what the requirements are for the berry industry, but if you don't have a property spray management plan, defining sensitive areas, outlining how you're going to manage those areas, I would suggest you create one of those. And if you're new to working for a farm this season and you haven't seen that, maybe ask to see that document, and you could contribute to updating that each year. Scott, have you got any final closing comments?
No, I think it's very good, Len. There's lots of topics here, and if we were to do a proper spray workshop, we could spend a week doing everything and including testing coverages and things like that. I've just recently been in Emerald for 2 days with an organisation up there looking at their citrus property, improving efficiencies and coverage and things like that. And that was a very quick trip, 2 days spent on farm all day for both of those days. So it does take some time, but it's a small investment to make sure you continue to have your social license. You're getting the best out of the products you're applying. You're producing quality produce, which is what the market wants, and it's around producing and delivering residue-free, good quality fruit to the market.
Yeah, and on that note, thank you for doing that. Get excited about berry season, so you do a great job. Keep it up. Contact the local Syngenta sales rep, and that way the question is answered, and both learn. The Syngenta rep learns. Because it might be something they might be able to address it very quickly and easily, or they might need to refer on to Len or myself, and then everyone learns in the situation and it improves everyone's general knowledge. Thanks, everyone. Thank you, everyone.